Okay, we continue with the part 2 of PCM. So here is the block diagram of PCM. So it consists of three parts. One is a transmitter, second is a transmitter part, and the last one a receiver. In PCM transmitter, the signal empty is first passed through the low pass filter of a cutoff frequency FM. So it use Hertz. This low pass filter block all frequency component above FM. This means that now the signal empty is band limit to FM. The sample and whole circuit then sample the signal at the rate of FF. Sampling frequency FF is like sufficiently about Niki's rate. So FF sampling frequency equal bigger to or equal to FM. So the output sample and whole circuit is denoted by TS. This signal TS is discrete in time and continue in amplitude. A Q level quantizer compare input and TS, which is it fixed signal level. It then align any one of the digital channel to MNTS, which result in minimum distortion or error. This error is called quantization error. Thus, output quantizer is digital level called MQNTS. Now the quantized signal level MQNTS is given to binary encoder. This encoder convert input signal to be digital binary word. This encode is also known as the digitalizer. In addition to this, there is an oscillator which generates the clock for sample and whole circuit and parallel to serial converter. In PCM, sample and whole quantizer and encoder combinedly from an analog to digital converter. So the part between PCM transmitter and receiver, over which the PCM signal level is known as PCM transmission part. The more important feature of PCM system lie in the ability to control effect of distortion and noise when the PCM have trouble on the channel. This is accomplished by means of using a chain of regulative repeater as shown in such a repeater are spaced close enough to each other on the transmission part. The repeater performs three basic operations such as quantization, timing, and decision making. And each repeater actually reproduces the clean and noise-free PCM signal. This improves the performance of PCM presence of noise. Okay, we continue with the block diagram of a receive. So the generator at the start of PCM receiver reshape the pulse and remove the noise. This signal is then covered converted to parallel digital word for each sample. Now the digital word is converted to analog value encode as MQT, which with the help of sample and whole circuit. This signal at the output of sample and whole circuit is allowed to pass through low pass reconstruction filter to get the original message called MT. So one more again for PAL code modulation. The PAL code modulator technique sample is the input signal MT at the sampling frequency. This sample variable amplitude PAL in then digitalized by the analog to digital converter. The signal is first passed through a sampler which is sampled at the rate of FF, where the output of sampler MTS, which is discrete in time, is fed to Q quantizer. The quantizer compare the input MTS, which is fixed level. It assigns any one of digital level MTS that result in minimum distortion or error. The error is called quantization error. Thus, the output of quantizer is a digital level called QNTS. The quantized signal level QNTS is binary encode. The encoder converts the input signal to be digital binary word. The receiver starts by reshaping received PAL, remove the noise, and convert the binary bit to analog. Okay, we continue with the step number 3, quantization. So sampling is like drawing a vertical line, but quantizing is like we drawing horizontal line. Then make it sample much one specific horizontal line.